Hello, good morning, everyone. Welcome to another episode of Sound Talk Show. So today we are going to do Wolfram language coding, a very interesting problem. Okay, so Wolfram language live coding, and I'm going to code a problem where, okay, so you read a text file or files in a directory, and you want to tally word count. You want to get a word frequency list, such as which word are used the most frequently, in English. So you can look up Wikipedia, the most frequently used word, I, you, me, how are you, where, things like that. So you want to, get all files and tally count the word frequency. That's one problem. The second problem is that you want to find the most frequently used in order, the most frequently used word pairs, like a phrase of two words or three words. So for example, you are, that's probably one of the top frequently used. Where are, that's another example. There is, what for, for example, when you use your phone to chat, phone will usually make such suggestions. So that's the, you want to tally the frequency of the bigram words. Okay, so that's the second problem. Now that's one problem. Okay, the other problem I'm going to do it together today is that you want to count the letter frequency. Which letter are most used frequently. Let's see. Let me show you. Okay, shorthand system. Okay, for example, you are looking at my keyboard. I mean, this is a keyboard layout. This is QWERTY, QWERTY. So the red circle, the bigger the circle, the more frequent that letter appears. So, for example, you have different keyboard layout. So you can see in this Vora layout, most frequently used letters are in a home row. So the problem is to go through a directory of files and tally, and to see which letter are most frequently used, get the order of them and percentage, so that is the two problems. And also then after that, then you want to do bigrams. Okay, so let me show you an example of bigrams. So you have letter layout, letter frequency. So I'm going to do this in Wolfram language today. Then perhaps tomorrow, in my next few videos, I'm going to do it in JavaScript, in Python, in Golang. Let me show you. Okay, so actually, since I'm doing video, it's better to just show and tell, since I'm doing it. So some programming language tutorials, I'm going to do it in Wolfram language today. Next week or few days, I'm gonna do the same problem in Emac Lisp, in JavaScript, in PowerShell, in Golang, in Python. Okay, can you see that? In Python, in Golang, PowerShell, So and let's compare which programming language is the fastest, which programming language is the shortest source code. I already know the answer. That's a Wolfram language because it's, because all these functions we need today is built in. Okay, hello Reaper, hello Immortality. Hey Immortality, are you the triangle guy on XAR server? Okay, so let's do it. Okay, so that is the background. That's what we are going to do. I hope 30 minutes, 40 minutes. Okay, so I need to keep my time. So okay, and let me show you again. Let me talk about the keyboard. So the keyboard you see I'm using. This is a fantastic, one of the best ergonomic keyboard. I recommend. It's cheap too, $100, $150. I recommend it very much. So you go buy it. They send me a sample. So and I really love it. So so I have like lots of tutorials on my website about this keyboard. Okay, and so you go check it out, and I recommend it. Next week also, I'm going to do a review of this keyboard by itself. Okay, so this is the Expos night. Okay, now Wolfram language, okay? Now, if you don't know, okay, so let's go to SAS Talk Show. Let's start to do stuff, okay? On the pink window is all my Emacs commands, okay? And so let me show you Wolfram language. So if you don't know, I did, 20 or 30 Wolfram language tutorials in the past. If you don't know, I'm not going to repeat the basic stuff, like where do you download, where do you download, how, I'm not going to repeat them. So if you don't know, just search for Xali Wolfram language. Then you'll find my Wolfram language tutorial and several those best of my videos. I collect them here, so you can start to watch them here. That one, which I've done a few weeks ago, and several others. So watch those, okay, if you are new to Wolfram language. So today, so that is the background. So let's copy and let's show today's talk show page. I make a record of what we talked about. So here's a showing browser. So you can see Expose Night keyword, okay, fantastic. Wolfram language tutorial, so you can people can go to it. And here is a description of the problem we're going to do. Do one file first, then we're gonna do all files in a directory. Okay, so the next question, let me talk about why do I need to do it. So the reason I need to do letter frequency count is because because I have this project of ergonomic keyboard layout. Ergonomic keyboard layout, right? Letter layout. So in this project, how do I know that E occurs the most frequent? How do I know the size of the circles? It's because you need a statistical data. So these are already compiled, but it's incomplete. So I need to do a lot more. And for example, you also need to do this for different languages, for French, German, different languages, or Russian. In the case of Russian, you have Russian. You have Russian language layout. You have French, and you have Russian. You can see. So you need to do this for every language and tally. So I need the statistics. Right now, I just have like very simple English. So that's why you need to know the letter frequency. Okay, and why do you need to know the letter bigram frequency? Because bigram means two letters together. You need to know which two letters happens the most. Why do you need to know that? Because when you study the layout efficiency, you want to find the best layout. The bigram is a significant criteria. It's a significant thing to consider when you are designing the best letter layout. So, for example, where is I have talked about that somewhere here. Okay, the most efficient layout. Let's see. Yeah, there it is. So you can see here is a pre-computed two-letter sequence bigram count. This is from Google actually, which is great. They base their corpus, the source from 10 million books, but the input source is significant, because you don't want when you design a letter layout, you don't want to base them on some academic textbook or formal writing, because when you type, to your mom, "Hi mom, what are you doing today?" or to your friends, you don't type those jargons, chemistry, physics, academic, style of writing, formality. So therefore, it is important when you do this kind of frequency and statistics. In the case of designing a keyboard layout, you want to consider what type of the input. Okay, for example, when today you have lots of typing websites. Type race, you can compete with your friends. The inputs are typically the most basic, commonly used English letters. But so let's say you can type 80 words per minute. But if you switch it to for example, a math textbook, you're gonna significantly significantly slow you down because the input matters. Okay, so this is the reason why I need to do, once I have the statistics, I'm going to replace this static image by a JavaScript generated, so I can, so it allows you to type your own input and get at least the frequency of bigrams. So that is why I need this project. So that is for the letter frequency, okay, letter frequency. Then the other project I need to do is to get the word frequency and bigram words, word phrases. Why do you need to do that? Because I'm creating a shorthand system. For example, these are abbreviations, okay, tentatively named XOR shorthand. Okay, so let me show you. So you are looking at my Emacs abbrev. For example, if I want to type the word reference, okay, I can just type RFR, okay, that becomes reference. So if I want to type the word question, it's just QQ, it becomes question, okay? So this is a brief system, in Emacs, I have like a thousand of them. So in order to tally this, you need to know, in order to design this shorthand system for typing, not for, there are lots of shorthand system for writing, for manual scripting, scripting style, cursive style writing. But this is a shorthand system for typing. So in order to design this, you need to choose, what letters to expand to what. You need to know the word frequency and also a phrase frequency. For example, I can type, for example, online, for example, very common. When you want to say, by the way, okay, press enter, it becomes by the way. You just type BTW. So that's a phrase that saves you like 10 keystrokes. Okay, this is a great hand saver. So I want to, of course, you need time to learn. So this is the reason you need the word frequency. Okay, of course, there are lots of reasons in crypto analysis and so on. So eventually, I'm going to write a JavaScript, interactive JavaScript page, so you can, paste or type, and you'll count your words and so on. So that is the reason. Okay. Okay. So now let's start coding Wolfram language. We already spent 10 minutes talking about it. Okay. So again, watch my old Wolfram language videos, okay, because I have the beginner stuff, okay. So let's begin Wolfram language, okay. Questions, comment, post it, okay. No, I'm not Triangle. My username on Discord is ccpimo. Okay, yeah, I recognize. Okay, let's begin. So Wolfram language tally. So first of all, so let's go to. Okay, first of all, let's go to Alice in Wonderland. Okay, so let's get Alice in Wonderland. Yeah, so vocabulary, etymology, literature, classics. Let's for something fancy. Okay, Arabian Nights, the story of the king. Copy it. Okay, Wolfram language. Let's see. Yeah. Started. Hey, wait, what are those? I have sticky keys on. So Wolfram desktop started. Is this show meta programming was created like literally writing a novel? Is this how meta programming is created, like literally writing a novel? What do you mean? I'm not sure what you mean. So starting Wolfram language, okay, Wolfram documentation, that's not what we need. We need to Wolfram language, okay? So there it is. Now magnify so you can see. So let's put this here and let's input, okay? X input. So here is gonna be a whole string. Well, there's a problem because okay, so let's the fisherman and the genie, okay, let's just say that. Now is there a Now enter. Okay. So we have our text input. Okay. Now actually I know, so we need to, first of all, we need to count word. Okay, count words. Okay, for each word, how many times it appears. That's what we need to do. And as it turns out, there's a built-in function for it. Fantastic, saves your time. That is the nature, that is the characteristics of Wolfram language. Almost, lots of things. Because otherwise you have to type, spend an hour just to code this. Let me show you, okay? I don't know where it is. So what you do is you just go to Wolfram documentation, search for Wolfram doc, okay? Wolfram language. I've been coding Wolfram language for 15 years, mostly in the 1990s. So there are 7,000 built-in functions. Everything is built in, 7,000 of it. So you click on stream manipulation, then you click on working with templates, you click on text manipulation and text analysis. That's right, text analysis. So all here is, the function we need is already here. Word count, okay, that will total number of words in a text, okay. That's not what we want. What we want is word counts, count of words or n-grams, okay. So that's a function. That's, and word frequency, okay, there are several, okay, so it's all built in. Then you have letter counts, then you have character counts, okay. That's all we, all the things we need is already built in, okay. So word count, word frequency, letter counts, character counts. Let's see. Let's do the word first. Word counts gives an association, which means a dictionary or hash table, whose keys are the distinct words identified in string and whose values give the number of times those words appear in string. That's what we want. Okay. Then you can also give a number, then that will give you n-grams, like two words phrase or 3 words phrase. Fantastic. That's fantastic. Okay, that's what we're gonna do. So word count, so easy. Wait, counts. Okay, so word counts. Yeah, and what is our variable x inputs? Okay, do it. Loading from Wolfram Research Server. Oh my god, I don't like it. That means it connects to internet. For some reason, this function is not in a kernel. I haven't spent time to look for why. Okay, so there it is. So and occurs 11 times. The occurs 9 times. That's just this paragraph. Okay, that's just this Arabian Nights, I highly recommend it. Okay, it's Arabian Night is this is Alan. Alan bought the book. Fantastic. Okay, you can buy this book or you can read my annotated Arabian Nights, The Fisherman and the Genie. Fantastic, wonderful story. One of my favorite top 5 favorite literature. Okay, and it's nothing like what Disney tells you. Disney is not. Disney is American Nights. 1001 American Nights. Okay, Fisherman and Genie. So that, the word count, that is just the first paragraph. So let's go back. So we already have the answer here. Okay, that's the so what we're gonna do now, so we can start to read a file. Yeah, that's what eventually I need to do. Let me just show you some other. Let's see. We can start to read a file, or we can start to do the letter count, because eventually we need to read the whole directory. And by the way, the return value, this return thing, that is a dictionary or hash table. In Wolfram language, it's called association. So if you don't know already, you can look into, let's close this, what is this, close, pop this back. Let's see, yeah, show today's talk show. You go to, my Wolfram language tutorial. I have the complete tutorial telling you what is association. Okay, so association list is here. Map array, delete element. So those are list position, and loop function advanced. Where is association? There is a data structure association. Okay, so in other languages it's called hash table or dictionary or map. Okay, so that's what it returns. Okay, there's a question about meta programming. So what is the question? JR, is this how meta programming was created, like literally writing a novel? No, I don't know what you mean. I just wanted to know how or what is the intuition to better understanding meta programming. Okay, meta programming basically you program your program in some sense. Okay, let's not talk about that. We can talk about the next. Oh Jesus, a spam. We gotta deal with spam. Add moderator, hide user, put God. Okay, so what we're gonna do next, essentially that's already the answer. What we're gonna do next is we want to, okay, let me just go through then. Okay, that's word count. Let's know what's the other. Word frequency gives the frequency of word in text. Okay, let's try that. Gives the frequency of words in text. Okay, so in this case you have to give a word, and basically it divides by the total. That's not what we want. We already have the frequency list. Basically the word frequency just gives you a percentage out of the total. You can compute it yourself. Okay, so that's not what we want. So let's look at letter counts. Okay, letter counts gives an association, a hash table whose keys are the distinct letters, right, and whose values gives the number of times those letters appear. That's what we want. Let's do it. Okay. So letter count. Okay. Run it. Okay, there it is. Now let's do bigrams. Okay, so consecutive two letters. Let's see the letter frequency. Okay, there it is. So fantastic, simple, so simple. So essentially we already solved the problem. Now let's do a bigram for words. Okay, so let's do bigram for words and let's see what we get. Oh my God, loading from Wolfram research. I don't understand why is this function not part of the kernel. Okay, letter count. Wait, what? Oh, it's still computing. I don't like this. It's talking to the internet and do the computing. But anyway, here's the result. Okay, so this result is not ideal because you see it includes the comma. Oh wait, it doesn't actually include the comma. But the reason it's all one is because our input text is too short. So you don't get things like it is, what is, where is, you are, things like that. You don't get it because our input is only one paragraph. Yeah, here. So okay. So essentially we already have what we want. Let's see what we're gonna do. Oh, there's a question. Do you prefer Wolfram over Python? Of course, by a magnitude. If you haven't seen my talk show, watch by a magnitude. Watch this video on my website, xali.info. Okay, xali.info homepage. Then this video, 2021, February 6th. You jump to 18 minutes. You'll see my kind of I give you a characteristics of different languages: Haskell, Perl, Ruby, Python, Java, Clojure, JavaScript, Lisp, and Wolfram language. Wolfram language is a magnitude better than them. Okay, as far as in terms of ease of use, in terms of superb documentation, ease of use, and understand the fastest way to do by a magnitude than all of them. Each line of Wolfram language equals to 10 to 10,000 lines of other languages, including Haskell or Lisp. The reason is because we are not even counting mathematical functions, because you can do integrals, solve differential equations, and so on. If you count those, then one line of Wolfram language is 10,000 lines of of all the others: JavaScript, Go, and Java. But if you do not count those, if you count things like just simple functions like this one, how many lines does it take to do a word count? Well, in Python, in most other languages, you do a hash table, then you tally like 10 lines, 5 lines. So okay, so what we're gonna do next, let's see. Now NLTK, no, I'm not sure, and Wolfram language includes lots of AI stuff, like what Stefan Wolfram would say is it has basically all the algorithms in computer science, all the practical algorithms you need built in. For example, you string Levithian, for example, word counts, letter counts, that's, you need an algorithm instead of building. Again, 7,000 built-in functions out of the box. You do not need to load the library. Like in Python, when you want a regular expression, you need to load a regular expression library. Same thing with Golang. If you want to traverse directory, you need to load a system OS library. That in Wolfram language is you just call the function right away. You don't need to load the library. Okay. So what we're gonna do next? I'm thinking maybe that's it for today. Let's keep this short. Okay, let's see. Actually, what I need to do is I need to traverse the directory, but okay, let's try to do that. Okay, so first of all, let me do okay, now let me do this in the XAR Wolfram language mod. Okay, let me show you what that is. So I have written a XAR Wolfram language mod in Emacs Lisp that allows you to code Wolfram language in Emacs Lisp. So you can see the the web page. You just search for it, you'll find it. It's on GitHub. Okay, and there's a video, so it's on GitHub. You just go to download. So it allows you to code Wolfram language in Emacs, because that way it's much faster. Okay, and you can download Wolfram language there. Okay, so So let's start to code that. Okay, so Wolfram, so word count, so completion counts. Okay, so input, so x input equals to, so we want to something. Okay, so word counts x input. So for example, I can evaluate that. Okay, so let's do the same thing. Let's copy the source code. Okay, this time let's just copy the whole thing. Okay, now open it. Okay, and remove all double quote. Wait, do I have double quote there? Because in order, okay, no, okay, copy it, close it, put the whole thing here. Okay, so here is a giant text, input text. Okay, so now let's run this word count. Do it. There it is. Wait, what? Okay, so it's repeating the output. So let's go down. There it is. Okay, so here is the result, word count. It's a long list. Let's see. Yeah, so you see happened 376 times and happened 319 times. Now you have lots of words. Now it makes sense. So this 200, that's a Unicode something. That's a curly quote, I think. Of happened 158 times. Okay, so let's do this again. Now let's okay, let's run it. Okay, so copy the text, new buffer, paste it here. Now let's make them into one, each line, each word by a line itself. So I'm gonna do some Emacs find and replace. Okay, now it's much easier to see. Okay, that's the word count. Okay, so close that, don't save. Now we also need letter counts. Okay, now words counts. Now let's do a word counts bigram and letter count. Okay, so there it is. Okay, so word count bigram. Okay, let's do word count bigram. Let's see what happens. You know, it's great when I'm using Wolfram script, it doesn't connect to internet, I don't think. So that is great. So here is the result. Now let's separate into the each line. Fantastic. So you can see, oh wait, I don't want that. So I want let's undo. So you want to replace that by wait, what do you want to replace? You want to replace that by a new line. Okay, do it. Okay, there it is. So the phrase, what is this 200 character? Damn. Okay, that's not good. That's so of the happens 33 times. To the happens 32 times. The fisherman happens 23 times. Fantastic. So that's bigram. Okay, so let's try trigram. What happens if you have trigram? I mean 3-word phrases. Let's run it. Hello, Yonghun Shei. Yonghun Shei. I don't know who are you. I don't know. So here's a result. And now replace that by a new line, replace all. Okay, so fisherman, the fisherman something. I think I think there's a flaw in Wolfram language here. This character, that's it's incorrect. I think it's wrongly read the curly double quote here. So you can see there are many Unicode characters, such as that thing. By the way, this is this is my work. I have annotated this work, so you can hover the mouse and see what withal means, and held, so there at. Yeah, so you can see there's a curly quote there. Might and men, that's a poem. So this story, lovely story, okay? The Arabian Nights, the fisherman and the genie. And then here comes a poem. Oh, toiler through the glooms of the night, in peril and in pain, thy toiling stint for daily bread comes not by might and men. Seest thou not the fisher seek afloat upon the sea, his bread while glimmer stars of the night are set in tangled skein. I love this, I love it. So go read it, okay? Search for Sadi Arabian Nights, you'll find it. Okay, so that's the word count. That's a 3-letter words count. This. So let's find out what happened here. Why are those funny characters? Let's see. So let's try to search this line. Ifrit, okay? Search IFRIT. By the way, Ifrit means genie, okay? In Disney speak, in American speak, that's genie, Ifrit. Okay, search again, Ifrit. Okay. Let's try this one, the Ifrit, okay? Search the Ifrit. Okay, search. Okay, I don't know which one is that. It happens a lot. Let's go to the bottom, okay? Let's see something. We want to try to find out what are these slash something. I think it's some problem with Wolfram language. It interpreted the encoding incorrectly, I think. Whoso shall. Okay, let's try to find whoso shall. Whoso shall. Okay, that's a single quote. Single curly quote, apparently. Let's try to do it again. Yeah, so whoso shall. So single curly quote becomes /230. Let's see if that's true, okay? So in Emacs, what you can do is, this is the power of Emacs. So a new buffer, type a single quote, magnify, and the code describe char. So it's going to tell you that the code point is 44. The code point is 44. Yeah, but in octal it's 54. In hexadecimal it's 2C. That does not explain where this 230 come from. So I think what happened is that the Wolfram language has encoding incorrect, I'm guessing. Okay, I think that's it for today. So 40 minutes. So yeah, so let's So we did word count. Now let's do letter count. Okay, let's just do letter count. Do it, run it. Okay, so letter count is pretty short. Copy it, new buffer, paste it here. Replace comma by comma, new line. Okay, letter count, fantastic. Letter count is easy. Okay, but now let's see letter count by bigrams. Okay, two letter consecutive letters. Okay, there it is. Copy, new buffer, replace. Okay, so it's not sorted. Okay, when you do letter count, it doesn't sort it. Okay, but we can sort it with Emacs magic, or we can sort it with Wolfram. I'm not going to do it. Okay, so close, don't save. Close, don't save. Okay, so that is the basically the solution. Okay, so now pop this back to a HTML page, show in browser. Okay, that is today's talk show. That's the input. Yeah, that's no good. That's because the input is so long. It's better if you read it from the text. Okay, let's do one more thing. Let's read it from a file. Okay, so let's get to the path of the file here. Okay, that is the file. Copy the file path back to Emacs and pop this Wolfram language out. Here is the file path, and let's remove the whole text here. So we want to read this file. So how do you read? Go back to Wolfram language tutorial. Then here is a read file. Read file. Okay, so that's what you do. Copy it. Okay, read and give a directory. So the directory file path is that. Okay, content. Okay, so that will be just X input. Comment that out. There it is. Now let's do this again. Word count, do it. Okay, so you need to put a semicolon so it doesn't show the input. Do it again. There is a result. Okay, so copy it, new buffer, paste it, replace comma by comma, new line, go to the top. There it is, word count. Fantastic. Okay, now since we are reading the file and the source of the file is a HTML file, so you start to get lots of these HTML tags. So now let's write another command to replace those HTML tags. So we're gonna do find replace. Any pattern like that, we're gonna replace, delete them. Okay, so let's do find replace. So how do you do find replace in Wolfram language? Well, there is finding string functions. So you go to string, then you insert into string, delete substring, search, test, pattern matching, and string replace. Okay, so that is what you want, string replace. Yeah. So what we're gonna do is that okay, so replace. So we're gonna string replace input. So here is the input, first argument. The second argument is you want to have a pattern. So in here you replace dog by cat, but what we want to do is a pattern here. So we want, let's use a regular expression. Okay, regular expression that and then here is anything not that. Okay, one or more. Okay, and replace it by empty string. Okay, and it returns a new string, so set it back to input. Okay, now let's run this again and put a semicolon here. Now run it. Now we will not see those HTML markup. Yeah, indeed, there it is. So new buffer, paste it here, replace comma by new line, replace all, go to the top. There it is. Fantastic. That's fantastic. That's it for today. That's it. So now our code is fantastic. Just very short. Delete that, clean up, put it back to HTML page, syntax color them, show in browser. There it is, our result, this Wolfram language code. Okay, that's it for today. Thank you guys for watching. If you pay me, okay, donate me, okay, like my stuff, pay me. So you go to Xa Talk Show, you go to my Xadi website, you can see at the bottom, Patreon me, Amazon gift card me. Okay, thank you guys for watching. Any other questions? Chinese 中文当然啦，我想开一个准备最近一直想很久了，开一个中文的视频，就是用中文讲解，我想讲解 Emacs， 所以大陆的朋友，因为大陆的很多以前大陆很多朋友捐钱给我，所以很多大陆喜欢看我的讲解，所以我开一个中文的讲解教 Emacs， 但是我想或者在 YouTube 上先开，还是或者是搞一个哔哩哔哩 B 站开。Okay, thank you guys. Bye guys. Okay, so next coming weeks, I'm going to write the same thing exactly like today, but I'm gonna do in JavaScript, in Emacs Lisp. That should be easy. In Emacs Lisp, in JavaScript, in PowerShell, in Golang, in Python. Yeah, that's the language I'm gonna do exactly the same thing. So then another day we're gonna compare which one is the fastest, which one has the shortest code. Obviously, Wolfram language. It's 2 lines done by shutting down in a minute. Okay. So I talked all the things I want to talk about. Yeah. So. Yeah, but we didn't do the directory, but that's easy. You just read a whole bunch of files in a directory. Okay.